Good afternoon. Thank you all for coming. Can you hear me? I am Ajoy Sarkar, and with me is Professor Kopelman, and we are going to talk about microplastics and its impact on mammals. And I'm going to set the stage here by giving you an introduction to microplastics and microfibers, and then Professor Kopelman is going to talk about the impact on mammals. And so let's begin with what are microplastics? And so there are many definitions for microplastics, but we'll begin with the definition by NOAA, which is plastics that are less than 5 millimeters in length. But within this broad definition of microplastics, there are many kinds of microplastics, and I'm going to focus more on microfibers because that's where our expertise in TDM, the Textile Development and Marketing Department, is. So microfibers shed from clothing made from synthetic fibers, and I do want to point out that natural fibers also shed microfibers as well. But the focus has mostly been on synthetic fibers because they take longer to degrade in the environment. And then microbeads, some of you that watched the movie about Watertown yesterday, and they were talking about microbeads in toothpaste, microbeads in cosmetics and other products. But there was an act passed, and that's the date in 2015, banning microbeads from most products. And then larger plastic debris, such as from tires and other plastic materials, and then pellets used in manufacturing as well. But as I said, we are going to focus more on microfibers from textiles. And I wanted to focus on this circle. And I wanted to notice that there is a microplastics, or the tendency to microplastics pollution to happen all the way from raw materials to fibers to yarns in the coloration and finishing processes to sewing and cutting. But also on the other side, I wanted to notice that a lot of focus now has been on care of textiles. So whether you're laundering as a consumer, where does the wastewater go? And then finally its impact on the environment, which is what also we are going to talk about today. And just to give you some perspective, some idea about this problem, just some numbers here, just some quantitative numbers here. So one load of laundry, about 1900 microfibers. 0 to 2 grams from each garment, and a single jacket, a single synthetic jacket, 1.1 grams of microfibers. And remember, we are 7 billion people on the planet, and just a single jacket, a single synthetic jacket, is 1.1 micrograms. Interestingly, there has been some studies to quantify what we can do to reduce some of the impact. And interestingly, as you see there, if you're using a front-loading machine, a front-loading washing machine, the microfibers tend to shed less. And part of the reason is that there is less agitation in a front-loading machine. Also, the other things that consumers can do is, of course, wash less frequently and use a liquid detergent as opposed to a solid detergent. So there are some things which we can do to reduce shedding. But let's look at the fibers first. So on the very left-hand side, on my left-hand side, it's a polyester cotton blend, and those are scanning electron micrographs pictures. The green jacket in the middle is polyester, and then you have acrylic on the other side. And I wanted to focus on the numbers. So this is the estimated fibers released per wash. And if you look at polyester in the middle, it's about 500,000. To add some cotton to the mix, high end, that's acrylic fiber. Closer to us, some things or studies that have been done. So a study was done to survey the Hudson River, the entire length of Hudson River, and the estimates are that about 300 million microfibers have been added to the Atlantic Ocean each and every day. And again, these are vetted studies, and I have those references down. So then the next thing becomes, so it is established that there are microfibers and microfibers are a problem. So what are some solutions? And maybe you've heard of some of these solutions. So for example, you can install filters in washing machines. Patagonia, along with some other researchers, they also have what they call as a guppy bag, or a guppy friend, where you place your clothing and that will trap the microfibers. And then the same folks that did the Hudson River study also have a device, a ball called as the Cora ball, which captures between 5 to 35% of fibers in test. And again, remember that all of this wastewater goes into wastewater treatment plants, and by estimates, a wastewater treatment plant can trap between 90 to 95% of microfibers, but that other 5% is still a big number. Some companies obviously are working on this. Leaders in collaboration with Barley for the Oceans. Last year, they made some 5 million pairs of shoes from microplastics, from reclaimed microplastics. But what we are trying to focus here at FIT, and particularly in TDM, is what else can be done. So trapping the microplastics, that is after the fact. So the garments are already shedding microplastics. So if you're trying to trap it using a bag, other methods, that is after the fact. But what can we do to prevent microplastics or microfibers from shedding in the first place? And so some of the things that the industry is trying to do, first of all, there is no standardized method of collecting sediments or sand and then quantifying them. So the first thing to do is to have a standardized method of collecting microfibers and then quantifying where all these microfibers go. So their final distribution, their fate, and how do they degrade, obviously, and then Professor Kopelman is going to talk about, obviously, on the impact on marine life. So with our expertise here at FIT, the various departments at FIT, we are going to focus, some of the research is going to focus on this. So how to develop a fabric, how to develop a textile, going by everything that I've written here. Develop a textile that will simply shed less. And that can be based on the fiber, the length of the fiber, the twist in the yarn, the construction of the fabric. But I also want you to remember that when fibers shed, fibers also have a coating on them, coating and chemicals. So whether they are dyes, whether they are durable press resins, ultraviolet stabilizers, any type of finishing agents. And so we are part of the APCC committee RA100, and that committee is trying to develop a fast test method to assess the potential of fabrics to launder. It is still in the development stage. So we'll be working with them as well. And then, as I pointed out, there are some recommendations to reduce the impacts of front load washer, reduce the temperature of water, and polyester, which is one of the biggest culprits. Polyester is very susceptible to hydrolysis by alkali. So when polyester comes in contact with an alkali, there is alkaline hydrolysis on the surface of polyester. And then the effect of softeners, the effect of liquid versus powder detergents. But the reason why we are all here today is because of a grant that we got from TDM got from Cotton-Aid, and the focus of the grant was firstly to educate consumers, students, the general public about the impact of this problem, about the enormity of this problem. And so what else can we do? But the first step that we did last year and we're continuing into this year is just education. And after the education, and then we'll begin on the actual solutions to the problem. So with that said, I will turn it over to Professor Kopelman, and he will take you on a journey to the sea.
Thank you. Can you hear me? Yes. Okay. So, I am, besides being a professor here, for 38 years, I am a marine mammal scientist, and I do spend a lot of time out at sea, and I've spent a lot of time over these 38 years with plastics out at sea. In fact, 38 years ago, I began one of my earliest work while looking for whales was also trying to quantify the amount of garbage and plastic that I encountered. And I worked up this entire detail of work of doing it, and it became overwhelming that I couldn't do it alone. And the whales got in the way, so I had to stop doing that. Maybe we'll do it again. So plastics at sea, we are floating in a world of plastics. In a figurative sense and in a literal sense, it's everywhere. And any of the plastics, you've all heard this, the plastics that have been released and used, they're still here. And a lot of those plastics make their way out to sea. There are so the latest estimate, over 5 trillion pieces of plastic weighing over 330,000 tons floating in the world's oceans. 17.6 million tons entering each year. Again, we heard about microplastics and various kinds of microplastics. There are also mesoplastics and macroplastics. They're all out there. And I guess one of the sad things is that when you test for or try and find plastics, the amount of microplastics out that you're collecting in your studies is well below what you would expect. And that's because those microplastics are making their way into the food web throughout the world's oceans. Plastics contribute to over 1 million seabird deaths and well over 100,000 marine mammal deaths every year. So this is a humpback whale. This is one I photographed in New York Harbor. And what you see, this is a nylon rope that this whale got entangled in. Humpback whales are big, not the biggest. They go up to around 60 feet, 80,000 pounds. They are relatively slow swimmers and often become entangled and are unable to break through that entanglement. So this one was swimming around in New York Harbor. There were attempts to remove that line that were partly successful. The first slide you saw where that arrow was pointing to another whale in New York Harbor that was also entangled in plastic. The entanglements include all kinds of organisms that get either ingesting plastics or entangled in plastics, and they run the gamut from crustaceans to fish, sea turtles, birds, sea otters, pinnipeds, which are seals, sea lions, and walruses, the sirenians, which are dugongs and manatees, and then cetaceans, which are whales, dolphins, and porpoises. Besides ingesting them, they also have problems with wounds, lesions. If they're ingested, they often block the digestive tract and can lead to death. I remember in 1994 being involved in a post-mortem exam of a dolphin that actually had a balloon in its stomach from a campaign for Congress in Brooklyn, I think. I've seen, this is years back, a Sowerby's beaked whale. The only live Sowerby's beaked whale ever seen in New York's waters. And it was dying. And this is 1994. We removed 20 pounds of plastic garbage bags. Yes, just this past few days ago, a sperm whale off the coast of Sardinia, a female with a dead fetus. They removed 88 pounds of plastic bags. A few weeks earlier, was it a sperm? I was having a senior moment. It was another whale that had 44 pounds of plastics. So sometimes it's not just stuff they ingest. Sometimes it's other things. What you see here is a humpback whale, and it's actually been entangled with fishing lines. You can just barely make out. You can barely make out, but you look at the bottom, the lower jaw, you see that line going across the surface of the water. Not a terrible kind of entanglement, but still problematic. Oh, here it is, monofilament line. This is a leatherback sea turtle. They eat jellyfish. They predate the dinosaurs. They live in all the world's oceans because they're essentially warm-blooded. So what is it eating, a jellyfish or a plastic bag? Can you tell? Maybe, maybe not. That turtle can't tell, and it is, in fact, a plastic bag. Sorry. This is a sperm whale. This is a healthy sperm whale out on the edge of the continental shelf, about 120 miles out. Sperm whales here in the U.S. are listed as endangered. Globally, they are listed as threatened or vulnerable. They are found in the world's oceans, and there are quite a number of them around, and they have been hunted for ages. Legal hunting for sperm whales ended in 1986 with the International Whaling Commission ban on commercial whaling. Just to give you an idea, in the 20th century, and this is mind-boggling, I know it's not about plastic, but from 1900 to 1986, 791,000 sperm whales were killed by commercial whalers. Insane. 874,000 fin whales. 380,000 blue whales killed by commercial whalers. What do they use them for? Blue whales and fin whales, predominantly for margarine and dog food. Now, not only they're not contending with hunting anymore, except for those that are still being hunted by Iceland, Norway, and Japan. They have to contend with garbage, with plastic. What you're looking at here are the contents of the stomach of the sperm whale. This is a paper published in 2013. Sperm whale in the Mediterranean Sea. It picked up most of that plastic from greenhouses and the debris field strewn from these greenhouses. And this is what's coming out of the stomach of that whale. This is macroplastic. They weren't looking for microplastics. Getting smaller, still macroplastic. This is a short-beaked common dolphin, one of the most abundant dolphins we have here in the western North Atlantic, about 375,000. It's one of my favorite pictures, too. And here's a paper from the coast of Spain. Microplastics in the stomach of common dolphins, Delphinus dolphins. Those microfibers that we just heard about, as well as other microplastics. 35 samples taken from stomach contents. 100% of the samples had microplastics. An average of 12 items per stomach. And these were dolphins that were stranded and then either stranded dead or euthanized because they couldn't be helped. not to leave. These are Atlantic bottlenose dolphins, actually photographed right here in the waters of New York Harbor. There are about 12,000 of them. This is the inshore bottlenose dolphin. And that's a pregnant mom. In case you're wondering how I can tell, her ribs are showing. Here's an inshore bottlenose entanglement. We use the dorsal fin to identify individuals. I can identify this one very easily by the entanglement. This is a Rizzo's dolphin. Deep ocean, this is out in a place called the Great South Channel. And was out there one morning, and this dolphin was jumping. I had never in 30 years seen Rizzo's dolphins breaching and jumping and jumping. The reason it was jumping is that it's entangled with fishing line. We heard about microplastics and their origins and a bit about their characteristics. I want to talk a little bit about some of the other characteristics that wasn't mentioned by Professor Sarkar. These microplastics end up, first of all, in the ocean. They're often found on a thin film at the surface, essentially lipids and stuff that is found that is lipophilic. They also have adhering to their surface, because they've got a large surface area compared to their volume, lots of toxic substances. So these microplastic beads end up being these focal points for toxic substances. They then get ingested, either by being ingested directly into the prey item. I don't know if this will work. Is there any way of, I have no idea how I can get that to go, but if it were to run, anybody know that? Magic. Click your heels 3 times. I don't think that's it. There, yes. See, I clicked my heels 3 times. This is plankton. This is a crustacean. Those green things are microplastics that have been treated with a dye. You can watch as this animal ends up ingesting microplastics. This is how it gets into the lower parts of the food web. These then get eaten by others. And those microplastics and the toxins they contain get sent to the next trophic level. I'm going to move to the next one, I hope. Oh, stop! Thank you. Speaking of plastics. Almost. One more time. Well, most of the whales that I deal with are large filter feeders. And what they do is they select dense patches of prey to swim into. I'm not going to bother showing this, but this is actually a video, it's an incredible video of a Buddha's whale just swimming into these massive patches of prey. And they do it at sort of fast speed. They turn sideways and just take in a tremendous gulp. This is a humpback whale. It can only take in about 5,000 gallons in a mouthful. And what you can see is the prey jumping out, but also in that mouthful, I'm sure, are microplastics. The fin whales that I work with can take up to 23,000 gallons of food in a mouthful. And here's a humpback whale ingested plastic. Died from ingesting plastic. The young one It had 137 cubic millimeters of plastic in its guts. And these are samples of the plastic from its guts. The fin whales, and you'll see in a moment, all right, this is a fin whale. And yes, it's being drafted by a couple of dolphins. Fin whales are these gulpers, take in massive quantities, again, 20 to 23,000 gallons of food and water per mouthful, not selective. And paper published in 2016 showed that fin whales in the Mediterranean have toxins from microplastics and actually have them in their baleen, in their blubber. The first evidence. They're feeding in places in the Mediterranean with a tremendous amount of plastic. I think the value is somewhere in the range of several 100,000 pieces of plastic per square kilometer. So when they feed, they're feeding on plastic, whether it's on the surface or in the water. 892,000 particles of plastic per square kilometer. Here in New York Harbor, it's not as bad, but we're still talking about hundreds of thousands of pieces per square kilometer. And this is a sampling study that was done that actually, according to a colleague, missed a lot. So their sampling techniques didn't catch it all. 165,840,512 plastic particles floating in the New York Harbor estuary any given time. 256,000 particles per square kilometer. And it doesn't just have to be here in New York. There's data collected from national parks all over the states. And they all have samples of microplastics in their water. I guess the take-home point is that we can do better. That it's not just the stuff that you're wearing, it's not just the stuff that you're throwing away, it's every bit of plastic out there that eventually becomes microplastics. And they end up in the water. So the idea is to reduce the amount of plastics. Just to give you an idea, this is a seal in the back there that's being strangled. For 8 years, he has come back. Here are 2 gray seals on the only gray seal rookery south of New England in eastern Long Island Sound. One up on the top on the right, strangled. One down here in front, also being strangled. This was a few weeks ago. A Cuvier's beaked whale, 40 kilograms, 88 pounds of plastic. And then we had a sperm whale just a few days ago, loaded with plastic. When I started looking at stuff about plastics many years ago, it was hard to find much information. But the amount of work being done and the amount of information out there is massive. With all that information, with all that work, with all the understanding and outreach to everyone here, I think it's important to know that we have an obligation to do better. We can't stop what's out there necessarily, but this is what you're trying to do, is to stop the source. Thank you.